Okay, so today we are comparing fractions. Comparing with the symbols less than, greater than, or equal to. We're going to, Waylon, we're going to learn a few different strategies. We've already learned one strategy, Owen, which was comparing fractions to benchmarks, right? Comparing them to 1/2. So just as a super quick review on how to compare fractions using benchmarks. If I give you the fraction 1/4 and 6/8, and I want you to compare those to the benchmark 1/2. What is half of 4?
2.
So this, since ours is 1 on top, that means this fraction is less than half, right? What is half of 8? 4. And 6 is more than 4, so this fraction is greater than half, right? So if we have one fraction that's less than half and one that's greater than half, then 1/4 would be less than 6/8. Okay, remember that?
Yep.
So here we go. Every year, oh, sorry, I got off track. So we've learned how to compare fractions using benchmarks. We're going to make good decisions, okay? Compare fractions using benchmarks. And now today we're going to talk more about using common denominators to compare fractions and common numerators to compare fractions. And then as a last resort, we'll use our fraction script to check over. Okay? Owen, you with me? Okay. Every year, Avery School has a fair. This year, 3/8 of the booths had face painting and 1/4 of the booths had sand art. Were there more booths with face painting or sand art? So they want us to compare the two fractions 3/8 and 1/4. To start with, what is half of 8? 4. And 3 is less than 4, so this fraction is less than half, right? What is half of 4? 2. And 1 is less than 2, so this fraction is also less than half, right? So we have two fractions that are less than half. So this benchmarks won't help us much in this situation. Go ahead and go get a drink, okay? Just go that way. Okay, thank you, honey. Hiccups are the worst. I don't like when I have hiccups. Okay, so one way, if we try to use the benchmark 1/2 and that doesn't work, is to use a common denominator. So think about this. 8 is a multiple of both 4 and 8, right? So we can multiply 4 times something and get 8. What is that? 2. And if you do it to the bottom?
You do it to the top.
Okay. Okay, so we're going to multiply 1/4 times 2 over 2. 1 times 2 is what? 2. So now we need to shade 3 8-size sections. Make sure you're writing this down. 3 8-size sections here. And then what do we shade next to it?
2 8s.
2 8s. So which one did we shade more on?
3 8s.
3 8s. So 3 8s is greater than 2 8s. Make sure you're writing what I'm writing. Okay, so that's one way we can do it, is to find a common denominator. A denominator that's the same on both. Another way to do it is a common numerator, and we've not talked about that before. So, ask yourself, Jace, is there something I can multiply 1 times to get 3?
3.
3. And if I do it to the top,
You do it to the bottom.
So I'm going to multiply 1/4 times 3 over 3. What is 1 times 3?
3.
And 4 times 3? 12. So now I have the fractions 3/8 and 3/12. Which one's bigger?
3/12.
You would think so, right? Because 12 is bigger than 8. Not on fractions. If it's on the bottom, it's talking about the number of pieces in the whole. So which is bigger, a 12th size piece or an 8th size piece? An 8th size piece. So remember, the bigger the denominator, the smaller the piece, okay? If you have a denominator of 100, that's a big number, right?
Yes.
But if you have a pizza that's cut into 100 pieces, those are going to be itty bitty tiny pieces, right? Okay, so listen, stay on track, okay? So 3/8 size pieces are going to be greater or bigger than 3/12 size pieces, right? 3 of these is bigger than 3 of these. And let's go fill that in. Okay, so we took 1/4 and multiplied it by 3 over 3 and got 3/12. Now we're going to shade 3/8 size sections again. And 3/12 size sections. So we shaded the same number, but the 12 size parts are much smaller, right? So 3/8 is greater than 3/12. Since 3/8 is greater than 1/4, there were more booths with face painting. So in this problem, we turned 1/4 into 3/12. We also turned 1/4 into 2/8, didn't we?
Yes.
Okay, so to find a common numerator, we turned it into 3/12. To find a common denominator, we turned it into 2/8. Oh, and look at this. If I flip back to my fraction strip and I find 1/4, look what's above it. 2/8. Look what's above that. 3/12.
It's all in order. It's all on the
Because
same
they're
line.
all equivalent. Remember, I said if they're above or below another number, those are all equivalent. So equivalent means you could just substitute it out for that number. Okay? All right. Here we go. Everybody get that copy down? We kind of talked about this, but why can you not use 1/2, the benchmark 1/2 to compare those fractions, Ethan?
Because they're both below the 1/2.
That's right, give yourself a point, because they were both smaller than half, weren't they? So the benchmark wouldn't help us in that case. All right. Compare the fractions. So this first one, the first thing you're going to do when you're comparing fractions, Dakota, the very first thing you'll do is compare them to 1/2. What is half of 4?
2.
So this fraction is,
Less. More.
pull up your mask, please. What is half of 4?
2.
So 3 is
More.
more than half, right? So we'll put a little plus sign above that. What is half of 3?
2.5.
What'd you say, Landon? No? Ella? 1.5. You have 3 cookies, you split them with your brother, each of you get a whole and a half of another. 1.5. So 1 is less than 1.5, right? So this fraction's less than half. So which is bigger? 3/4. So you've got one fraction bigger than half, one smaller than half, so 3/4 is greater than 1/3. And we found this out by using benchmarks. They gave us space to write a whole lot, but I'm gonna get through this quicker than that. Okay, on the next one, we've got 3/5 and 3/8. We're gonna skip over, I know I just told you to use the benchmarks first, but they've given us a common numerator here, haven't they? So which is bigger, 3/5 or 3/8? Remember, 8 is bigger, so that means it's smaller pieces. 8 is a bigger number, so it's the opposite of what you think. If you have the same number on top, Sophie, focus, okay? If you have the same number on top, you go and look at the denominator. The bigger the number, the smaller the piece. So we have 3 little pieces and 3 bigger pieces, which is bigger. 3/5. Okay, so our reasoning is 5th size pieces are bigger than 8th size pieces. Fifth size pieces are bigger than 8th size pieces. So when you have the same number of pieces, you look at the size. Okay? Okay, the next one is 3/4 and 7/8. Okay. What's half of 4?
2.
2. So this is bigger than half. What's half of 8? So this guy's bigger than half. So what should we do? Ella, what do you think? We just did that and we figured out that wouldn't work because these are both bigger than half. Reese? That's what she just said. And we just used benchmarks. We just figured out that this is bigger than half and this is bigger than half. So benchmarks didn't work. Landon?
Which has the bigger denominator?
In order to look at the denominator, they have to either be the same. We need to either have the same numerator, a common numerator, or a common denominator. Which would make the most sense for this problem, do you think? A common numerator or a common denominator? Sophie?
I think a common denominator.
Okay.
Because that's half of 8. 4 is half of 8.
Yes, girl, because you can multiply 4 times something and get 8, can't you? Can you guys multiply 3 times something and get 7?
No.
No. But Sophie, give yourself a point. Nice job. We can multiply 4 times something, or 4 times 2 and get 8. And if we do it to the bottom,
Do it to the top.
so now we've got 6/8 and 7/8. We got 2 pizzas, both with 8 pieces, both the exact same size pieces. Cash eats 6, Reese eats 7. Who ate more? Reese, okay? 6/8, 7/8. 6/8 is less than 7/8. Got it? Okay, so on this one we used a common denominator. Because eight is a multiple of 4 and 8. So in other words, we can turn 4 into 8 and keep 8. Okay, the last one of these says 4/5 or 2/3. So, start with benchmarks. Half of 5 is what?
4.5. 2.5.
Picture it.
It's 2.5.
You can always draw circles. 5 circles. 1 for you, 1 for you, 2 for you, 2 for you, and a half. So 2.5 is half of 5. If you have 4, you've got more than half, right? Okay, what's half of 3?
Just 1.5.
1.5. So again, we've got more than half. So benchmarks wouldn't work.
Let's use this.
Just because they're both bigger than half doesn't mean they're equal. Cash, if you look over here, all these fractions are bigger than half, but they're not all equal, right? So Sophie, what do you think we're gonna do?
I think we're going to use common I forgot what the top was. Numerators, because 2 is half of 4, and if you multiply 2 times 2, it's 4.
Yes, girl, yes, you're getting it, Sophie. Nice job. So we had 4/5 and 2/3, right? Sophie's like, well, I know that I can multiply 2 times 2 and get 4, but I can't multiply 3 times anything and get 5, right? So 2 times 2 is 4, and 3 times 2 is 6. Okay, I'm going to ask you, pause before you answer. Which is bigger, 4/5 or 4/6? Colin?
4/5.
Yes. Okay. 5's smaller, but when it's on the bottom of a fraction, it's bigger. Give yourself a point. Sophie, did you give yourself a point? Okay. So 4/5 is greater than 4/6. And 2/3 was also 4/6. So, common numerator. Because 4 is a multiple of 2 and 4. Okay, look at those two. Look at those two questions. Look at those two fractions. Which one? I want you guys to talk over with the people sitting near you and figure out whether you would use common numerators or common denominators.
You can do 6. Yeah, 6. Well, is in
I know you know, girl.
I beat her in saying it.
Okay, I want you to, if you, put your hands down. If you think that we should use common numerators, raise your hand. If you think common denominators, raise your hand. Dakota, how come common denominators?
Because 6 is half of 12.
Yeah! Give yourself a point. I love it. Okay, because 6 is half of 12, so we can double it and make it 12, right? So 10 twelfths and 11 twelfths.
11 twelfths would be bigger, wouldn't it?
Yep.
Yeah.
Okay,
Put it like right there.
so we're going to write common denominator. Because 12 is a multiple of 6 This next one's going to require a little bit of thinking. 8/10 and 3/5. It says, can you use simplest form to compare 8/10 and 3/5? Simplest form. Cash, what do you think?
5 is half of 10, so 5.
No, we're talking about simplest form now. We're not talking about common denominators. Okay? This is I like how you're seeing that though. That's awesome. Jace?
No, because yes, because 5 is half of 10.
Okay, that's exactly what he just said. And we're not doing common denominators. Ella?
No, because they're both half, one half.
Okay. It says, can you use simplest form to compare 8/10 and 3/5? I'm going to give Ethan a shot, then I'm going to explain. Ethan?
No, because 8 and 3 aren't the same.
No. Okay. Simplest form. Everybody go to your orange thing. Everybody circle 8/10. 8/10. It's right here. Everybody circle 8/10. Ethan, are you changing your answer?
Yes,
Okay.
because only one of them is simplest form.
No, but look, Ethan, what is simplest form for 8/10?
4/5.
4/5. Could you compare those two?
Yes.
Oh, are you guys seeing? Okay. Simplest form for 8/10. So you guys remember at the beginning I told you that bold fractions mean it's the simplest form, right? So 8/10 underneath it is its simplest form, which is 4/5. If I just gave you the fractions 4/5 and 3/5, could you tell which was bigger?
Yes, 4/5.
So instead of, normally we've only been multiplying, right? We've been multiplying to find common denominators and common numerators. But simplest form in this case would allow us to find a common denominator. So that's what it's saying. If you're trying to compare 8/10 and 3/5, it should be right here, and you found out that 8/10 is the same as 4/5, then you can easily see that 4/5 is greater than 3/5.
Are we able to take this home at the end of the year?
Okay, this is not the time. Can you use simplest form to compare 8/10 and 3/5? Yes. SF for simplest form of 8/10
And I dropped something.
equals 4/5, and 4/5 is greater than 3/5. So 8/10 is greater than 3/5. Basically, we've been turning the fractions into other numbers by multiplying. When you find simplest form, you divide. So they're just wanting you to understand you can change the fractions by dividing as well to find simplest form, or to find a common denominator.
I'm gonna just drop something.
Huh?
I'm gonna drop some stuff off.
Okay. All right. I'll give you another second, and then we're going to go to the last page. So.
Oh, this is quick.
Know that she's gonna work on the photos.
Okay. Turn to the last page real quick.
This is the last page we're gonna do.
Or not the last page, the next page, because the last page you're doing on your own. Okay. Real quick. Okay. Compare 2/5 and 1/10 we're going to use 10 as our common denominator. We're going to take 2/5 and multiply it by 2 over 2 to get 10 on the bottom, and that turns 2/5 into 4/10. Since 4/10 size parts is greater than 1/10 size part, 2/5, which we figured out is equivalent to 4/10, is greater than 1/10. Okay? And we were comparing 2/5 and 1/10. Let me show you how to do this with your fraction number line. Okay, if we're comparing here, 2/5, no, was it 2? Yeah, 2/5 is right here, and 1/10 is way over here by 0. So which is bigger?
2/5.
2/5, which is also 4/10. So 1/10 is smaller than 4/10. Okay. Okay, we're going to compare 6/10 and 3/4. 6/10 and 3/4. We're going to use 6 as the common numerator. We're going to take 3/4 and multiply it by 2 over 2, and that'll give us a 6 on top and an 8 on the bottom. So we've turned 3/4 into 6/8. So which is bigger, 6/10 size pieces or 6/8 size pieces, Brindley?
3/4.
Which is bigger, 6/8 size pieces or 6/10 size pieces?
6/8 size pieces.
Good, very good. So 6/10, our 10 size part is less than an 8 size part. So 6/10 is less than 6/8 or 3/4. Okay, we're going to do 4 more together, and then I'm going to have you guys do some. Just a reminder, step 1 is to compare fractions in a minute using benchmarks. That's what you do first. Step 2 is to find, or another option would be find a common numerator or denominator, whichever one works the best. And then step 3 is to check with your fraction number line, the orange thing. I'm writing that now because I know some of you are going to try to get ahead of me and I don't want you to. Okay. So 7/8 and 2/8. They've already got a common denominator for us. Which is bigger, 7 8-size pieces or 2 8-size pieces?
7 8
7 is more. 7 8-size pieces is greater than 2 8s. Did somebody say 2 8s? So when the denominator's the same, then you're just going to say, look at the number of pieces. Okay? So we have one pizza cut into 8 slices, another pizza cut into 8 slices. One kid eats 7, one kid eats 2. Who ate more? The kid who ate 7. Make sense? Okay. 5 12s and 3 6. All right, so let's start by comparing using a benchmark. What is half of 12?
6.
So this fraction is less than half, right? What is half of 6?
3.
3. So this one equals half. We've got one smaller than half and one equal to half. Which one's bigger? The one that's equal to half. So 5 12 less than 3/6. Oh, we have a common numerator here. So we have 4 tenth size pieces, and then we have 4 sixth size pieces, which is bigger.
1/6.
4 sixth size pieces. So 4 tenths is less than 4 sixths. And then benchmarks, what's half of 12?
6.
What's half of 4?
2.
Since both of these are equal to half, they are equal. Okay, and then we're going to check them on our fraction number line. Oh, by the way, guys, on the fraction number line, the only 2 denominators that aren't there, Owen, are 7th size pieces and 11th size pieces. But I don't think any of the problems have those today. Yes, Waylon?
How come we did the same for every problem except for this one? The one that we didn't put by
What number are you talking about?
number 5.
Number 5, we didn't have to do comparing to benchmarks because they already had a common numerator. They already had the same number on top. These already had the same number on bottom. Okay? All right, here we go. 7/8 and 2/8. So we come over here, 7/8 and 2/8. Which is closer to 1 whole? 7/8, and so we were correct. Okay? Our next fraction was 5/12 and 3/6. 5/12 and 3/6. Which one's closer to 1 whole? 3/6. So we got that one right. Next we have 4/10 and 4/6. 4/10 and 4/6. So 4/6 is closer to 1 whole. And the last one, 6/12 and 2/4. 6/12 is here and 2/4 is here. So those were equal. You get it? All right.
Another way you could find
That is it.